Hi folks, we're going to talk a little bit more about atomic structure, and we're going to talk about an ion and what those are, and why there's two types. So I'll leave this model of this electron here for the purpose of this discussion. And again, this model here is representing a lithium atom, and I know this because I have 3 pluses in the nucleus, which means that it's atomic number 3. And if you look up atomic number 3 on the periodic table, what you'll find is that element is called lithium. Now, there's something very special about this picture that I want you to notice. We've got this electron out here, and this electron is bound to the nucleus by this force that we've been working with for the last few weeks called the Coulomb force. This negative charge is attracted to the positive charge in the nucleus. Okay? Now, when these when these shells get bigger, the distances get bigger pretty fast. The second one is usually, give or take, about 4 times bigger than the first one. So what happens is that if we kind of compare the charge in the nucleus seen by this electron to the charge in the nucleus seen by this electron, they're not really the same thing. This electron is basically attracted to all of this charge because all of this positive charge is in this region in space. However, as far as this electron is concerned, the central location of the atom is kind of like this entire region. And as far as this electron is concerned, the effective charge in this area is really only positive 1 because there's 3 pluses and 2 minuses all in the vicinity of the nucleus as far as this person's concerned, or this electron is concerned. So, for that reason, the Coulomb force that's attracting this electron to the nucleus. Now keep in mind that the Coulomb force depends on the charges and also the distance. The Coulomb force is a lot weaker than the Coulomb force on this charge because this charge sees less charge than this electron. Now there's actually a second reason why this Coulomb force is a lot weaker. Because the distance is so much further. The distance between here and the distance between here and here is a lot greater. So for a second reason, this Coulomb force holding this electron to this nucleus is many, many hundreds of times smaller than the Coulomb force holding this electron to the nucleus. Maybe not hundreds of times, but many, many, many times smaller. So this electron, what we say is that it's not tightly bound. It's pretty easy to remove this electron because this force keeping it in orbit or keeping it attached to the nucleus is relatively small. This guy doesn't see as much charge, and the distance is a lot greater. So because this force is pretty small, it's pretty easy to just get rid of that electron. And the resulting atom now is positively charged because we have 3 pluses in the center and only 2 electrons. So by the time you add up all the pluses and minuses, you end up with a charge of positive 1.6 times 10 to the minus 19 coulombs for this atom. Right? Or the shorthand notation, people like to just call that a charge of +1. This type of atom, where it's missing an electron, is called a cation. In fact, all positively charged atoms are called cations. And this is how they become positively charged. An atom can be missing 1 or 2 electrons from their outermost shells, in which case they are positively charged and they're called cations. Some atoms, it's more natural for them to want to steal an electron. Right? They have a property called electron affinity, and they just naturally want to grab electrons from their neighbors. And in that case, they have extra electrons, and they're negatively charged, and then you get an atom or an ion called an anion. Right? So we have 2 types of ions, cations and anions, and the difference between them. Cations are missing an electron or 2, or maybe sometimes 3, and they are positively charged. Anions have gained an electron or 2, and they're negatively charged. All right, now, let me put this electron back so that it's not an ion anymore, and we have just a neutral lithium atom. The other thing that can vary a little bit is the number of neutrons in the nucleus. Right? And the reason it can vary is this. The protons in the nucleus are all repelling one another. So I like to think of a nucleus, it's almost like a little bomb that wants to go off. But it's being held together by a force called the nuclear force. And the nuclear force exists between protons and neutrons. So it's kind of like a glue in the interior here, kind of holding us together. The nuclear force is a very short-ranged force, so it only comes into play when these particles are very, very close, for all practical purposes, touching. And the nuclear force is what's binding this thing together. So what can happen is a neutron can get in this region fairly easily because it's not repelled by the nucleus, it's not repelled or attracted by the electrons. And if it comes in here, it can basically get in here and maybe kind of get stuck in here. And now what we have is we have an atom with more neutrons than protons. And as far as the heavy atoms in this atom, the heavy particles in this atom, the protons and the neutrons are far heavier than the electrons. So the vast majority of the mass of an atom is contained in the nucleus. So atoms can actually vary a little bit by mass because some of them can have an extra neutron or two or three. And so atoms with different numbers of neutrons are called isotopes. So that's very important. You're going to want to write that down. Right? Isotopes. You're going to write this down. They're atoms with different numbers of neutrons. And the reason you can have different numbers of neutrons is because they're bound by, the nucleus is bound up by the nuclear force. And these extra neutrons can get in here pretty easily and be attached to the nucleus because the neutrons are not repelled by the protons. Right? So now we have, when we look at an atom, and you're trying to predict how many protons, neutrons, and electrons it has, here's what you look at. The first thing you look at is the atomic number. The atomic number tells you definitively how many protons are in the nucleus, and that number cannot vary. Usually an atom will be expected to have the same number of protons and neutrons, but they don't have to. It's very common for atoms to have extra neutrons or maybe several extra neutrons, in which case you have what are called isotopes. Also, usually an atom would be expected to have the same number of electrons as protons. However, they don't have to. Lots of atoms like to give up an electron or two, in which case you would have positively charged ions called cations. And lots of atoms like to gain an electron or two, in which case you would have negatively charged ions called anions.